Welcome back. This will be the last part of the module working with numbers and introduction. And in this part, we are going to look at binary numbers. What is the binary number system? Well, the binary number system uses only two symbols, a 1 and a 0. And it is used in computers where 1 means on and 0 means off. It simply means that that little switch is either on or off. And we read it as 1001. That number there with the 1, 2 zeros and the 1 is not 1001 as we have it in the decimal system. In the binary system, it is the number 1001. It uses 2 as its base because it's only got 2 numbers in the system to calculate any value. So really 2 to the power n, and it starts on the right-hand side, the position 2 to the power 0, and then we move to the left. And as we move to the left, the power of 2 increases all the time. Let me explain to you a little table there. You see there's a table there with 11 columns and 2 rows, and in the top column here I've got the position of the 2, so that think of this as position 2 to the power 0, position 2 to the power 1, position 2 to the power 2 or 2 square, and then it increases to the left. And then in each case I have given you the value of that in the row beneath. So 2 to the power 0, anything to the power 0, you already know is 1 is 1. Anything to the power 1 is the thing. So 2 to the power 0, 1, 2 to the power 1, 2, and then 2 squares for 2 cube is 8, and it continues, it doubles every time we go to the left. Now keep this in mind because you're going to need to remember this when we convert decimal numbers to binary numbers and binary numbers to decimal numbers. So how do we count in binary? So switch position, first position is 2 to the power 0, switch that position on, and then that becomes a 1. This means that there now is only one value at 2 to the power 0 only. This is the only time where decimal 1 and binary 1 is the same. So what do we do when we get to 2? Well, we switch the position 2 to the power 0 off, and we switch position 2 to the power of 1 on. This means a value at 2 to the power 1 only, which is 2. Okay. So binary 2 is, or binary 10 rather, will be equal to decimal number 2. Why 10? Position 2 to the power 0 is now off, and 2 to the power 1 is on. Remember, we're moving from the right to the left in this case. What do we do when we get to 3, decimal 3? Well, we keep position 2 to the power 1 on, and we switch position 2 to the power 0 on as well. And then the decimal equivalent of 1 in binary will then be 3, or the binary equivalent for the decimal number 3 is 1. And so any decimal number can be written as a binary number, and any binary number can be written as a decimal number. But we're not going to count one by one and able to do it. There's another way to do it, and I'm going to show you how to do that just now. So here we can, I just summarized this for you in a little table. So the decimal number 1 to up to 10, and then I've explained what's happening to base position 2. So this is just a continuation of what we did on the previous line. So after 4, the binary number is 100. 5 then becomes 101. 6 then become 110. and 7, then 1, 1, 1. And then when we get to 8, sorry, I need to go back there. Then when we get to 8, we introduce a new position again, 2 to the power 3, and so on. Now I want you to notice something here. Notice that all even numbers end with a 0, and all uneven numbers end with a 1. So if we're adding longer binary numbers, now this is the binary number itself that we are adding. This is the way we do it. We write the second number under the first so that their positions correspond, as we would do when we were adding decimal numbers. Then start adding from the right following these rules. If you're going to add a 0 and a 0, it's going to remain 0. If you're going to add a 0 and a 1, it's going to become 1. If you're going to add, because I mean these are your only options, if you're going to add a 1 and a 1, you're going to get a 0, but then you will carry a 1 over to the next position on the left. I'm going to show you now. So 1 plus 1 plus 1 is 1, but then you carry over 1 to the next position on the left. So let me show you here. So here we have the two numbers that we are trying to add together, the binary number 1111 and the binary number 110. So here we go. 1 plus 0 is 1. That's the rule. Nothing else needed to do. 1 plus 1 is 0, but then we carry over the 1 to the next position. Keep on going back. Apologies for that. Now in this column here, we have 1 plus 1 plus 1, which is 1. But we carry over the 1 to the next position, where we have 1 plus 1, which is 0, but a 1 is carried over to the next position and is then just written as a 1. And that is how we add in binary. Now let's look at what we do if we are convert a binary number to a decimal. So I've given you a binary number there. It's the binary number 10111. Okay. So what do? We write the corresponding binary positions and their value above the number. So there's the number. I've just repeated the number 10111. And above that, I'm writing the binary position 2 to the power 0, 2 to the power 1, 2 to the power 2, 3, 4, etc. And then I write that binary number value in there. 2 to the power 0 is 1, 2 to the 1 is 2, 4, 8, 16, and so forth. Then we go and we look at the binary number again, and we ignore the positions with a binary 0 number. So here is the only 0. So this value of 8 we are going to ignore when we are trying to establish the decimal number. And that's why you have it, the double strike through there. And then the values that remain, the 16, the 4, the 2, and the 1, we simply add that together, and we can then write down the decimal number as 23. Okay, that's how easy it is. Similarly, it is as easy to convert a decimal number to a binary number. So this is how we do it. Convert a decimal number to a binary number, and I've given you a number there, 118. This is what we do every time we are going to divide by 2. So we say 118 divided by 2 is 59 on the dot. There is no rest. If it was 59.5, it would be rest 1. But now there is no rest. There won't be. It is an equal number divided by 2, so it will be another full natural number. And when it is a number without a rest, we say it is a 0 there. Then we take the 59 and we divide that by 2. But when we divide 59 by 2, we see that it's 29.5. And the moment we see 0.5, it is the same as rest 1, and then we put a 1 in the binary position. Now we've accounted for that 0.5. So we're not going to have to account for it again. So now we simply ignore it and we say 29 divided by 2. What is it? It is 14.5 because it's a 0.5. There's a rest 1. We put the 1 in the binary position. Now we can ignore that 0.5. So it is 14 divided by 2. That is just 7. It's because it's an equal number divided by 2. So the binary number there will be 0. 7 divided by 2 is 3.5 or 3.5 or 3 rest 1. So we put the 1 in the binary position. 3 divided by 2 is 1.5. So we're going to put the 1 in the binary position. And this is where we end. The moment we get to 1 or 1.5, we'll say 1 divided by 2 is 0.5. And therefore, it is a binary number 1. And then a binary number can never start with the number 0, because then it means that's off. So because a binary number must start with the number 1, we can go and we will read this from the bottom up, and then the binary number becomes 1, 1, 1, 0, 1, 1, 0. And that is how we convert binary numbers to decimal numbers and decimal numbers to binary numbers. Thank you.